Hello all. I would like to start the webinar on the design patterns. It's also called, we have made a caption like tailor-made solutions to the software development. So, coming to myself, I'm Nagendra. I'm working as a consultant in Edureka, and I'm an SME in the design patterns. I have more than 10 years of experience in software architectures and designing of complex distributed systems. So today we'll be going through the design patterns webinar. By the end of the session, you all will be able to understand the need for the design patterns, and you would be able to understand how we can build a flexible design using design patterns. And we'll be going through quickly about the UML diagrams, describing the diagrams and designing the diagrams. We will be going through a quick glance at the code with AbstractFactory Pattern, and we will talk about how to use observer pattern and the mediator pattern. So let's find a pattern over here. Here you have seen, you're seeing there are almost 5 sequences. These are very popular sequences you might have came across during any of your school-age competitive exams and aptitude exams throughout the career as well. So in the first one, if you could find, there is one hexagon and then one diamond, and then 3 hexagons and 1 diamond, like that. And similarly in the second sequence, we have squares and the hexagons and stars combination. You'll be able to easily find out what could come in the next blank. So that means, like, you know it in advance? No. By looking at the pattern, how the previous sequence is going through, you would be able to identify what would happen next. So similarly, in the below sequence 1, 3, 5, obviously one could easily imagine it would be a 7, because we know each of these numbers are differentiated by 2. So the pattern is nothing but identifying a sequence of the past and predicting the next outcome. So you guys would have find out, like, patterns over here, the sequences, whatever we have shown in the previous slide, these are all filled up here. The patterns are easy to recognize and they are everywhere. And the beautiful thing is we come across them every day. Today, let's suppose you have seen a traffic in one of your particular road. Tomorrow also you would see the same way, but you would not see the traffic during the weekend. And this kind of pattern will let you know how to plan for the next work week. So you would be able to identify when the traffic would be more and when the traffic would be less, and you normally do it. This is one of the popular pattern which everybody come across during their daily life. Similarly, the design patterns also follows a similar kind of principle, and hence we are naming it as a pattern. So, software development programming problems. What about the software development programming problems? Do we have a pattern for all these? Yeah, we do have a patterns even for the software development programming problems. Because not only our daily lives, we also face similar kind of problems during the software development environment. So till now, since the development of the industrial revolution or else the software development, there were quite a few applications have already been developed, and during this development, lots and lots of architects, lots and lots of designers, programmers would have faced similar kind of design problems throughout their career and throughout their projects. So what they have done is, rather than just finding out the solution and forget about it, they have noted down the context of the problem, and they have made a solution, and they have verified it works well even for similar kind of problems. Similar kind of problems. So we'll be going to the next slide. Software patterns describes the classes and interacting objects used to solve a general and repeatable design problems in a specific context with a proven solution. These are the, whatever you are seeing the picture, they have like, it's Eric Grama and Richard Helm, Ralph Johnson and John Weitz. You must have heard about this Gang of Four, a book which is famously known as Design Patterns and Elements of Reusable Object-Oriented Software. This is one of the most popular books among the software designers, and this talks about the design patterns agnostic to the programming language. It has nothing to do with the programming language. It doesn't talk about any syntaxes or semantics. It talks about how the design patterns will be identified and how what they identified during their careers, their design issues, and their experiences. So they have wonderfully kept down different kind of design patterns and classified them among the different flavors, and made sure most of the design patterns would be easily and blindly can be applied to any kind of the design problems, whatever the general software programmers encounter. The importance of the design patterns. So why do we need to, first of all, why do we need a design patterns? Is it for a good job, or is it for a good application development? There are plenty of reasons to understand, to learn about the design patterns. Unlike any other application software development companies, there are few companies who are completely concentrated on product development, not for just clients, but all for the general use. Something like Google, Microsoft, Amazon, all these kind of big Tier 1 companies, they don't choose for a particular skill. Like, if you got a Netezza data warehouse experience, they don't bother. If you have some original product, they don't bother. They bother about only the design pattern knowledge, like how you design a particular given problem, or if you are given some kind of a situation, how you design in terms of software. That is the main skill these Tier 1 big companies look for. So why don't they need somebody who has a particular skill? Because skills, like, for a particular product skill, you can develop by reading or going through the workbooks or any kind of documentation. But the design patterns is a skill that need to be imbibed in one's neurons of the brain. So they have to understand how to design and how to visualize a particular problem in a software applications. So you can visualize the prevalence of design patterns because most of the current software applications are being developed by OOP paradigm, as most of the design patterns are proved around the object-oriented programming paradigms. Most of the programmers think that both are related. In fact, as I said, the Gang of Four design pattern book never talks about a particular programming language, but still most of the current programming languages have a OOP support. Even the Python or Perl were never targeted or were designed in terms of object-oriented programming principles. But later, with the prevalence of the object-oriented programming, they have introduced OOP concepts even inside their scripting languages. So design patterns have nothing to do with the object-oriented programming. It is a tried and a proven solution to commonly occurring programming problem. To illustrate the design patterns, I'm taking one example over here. Let's take this example problem statement where we have a cement factory. It could be any factory or a pickle factory or a cheese factory, whatever it could be. It's a factory. Take an example of a factory, and if we are asked to design that factory, what all the key stuff we first look at. Let's consider one of the factory over here. It has lots and lots of supply chains, operation chains, wherein there are multiple materials constantly brewing. So one of the container would be controlling one raw material, and another container would be looking at another catalyst. So each of these containers need to be monitored in terms of temperature and flow and speed and mixture capacity, viscosity and all. So the data is captured using sensors for all these containers and then pass it to the master control system, wherein using the master control system, we monitor and control the ingredients temperature, flow and speed to provide a better quality final product. Because these machines need to be operated in a coordination. If either of them operates in isolation, the other dependent components of the containers would get spoiled. So let's suppose if the temperature of the mixture is less than required, then the master control system should send the increased temperature command to the machine. So how can we build such an automated system? There are two ways. The one is using a procedural programming language, and the another is visualizing the whole factory in terms of objects and use it as an object-oriented programming. So let's look at the requirements. There are different entities monitoring the data generated by these sensors. Each entity takes its own decision on data and informs others as well at times. There is also a master management control room from where the commands to different entities may generate. And then the data from these entities should also report back to the master management control room. Let's look at them in visual diagram. This is the master management control system, and this is the packaging entity, and this is the chemical control entity, and this is the catalyst control entity. For delivering the final product, we need to have a chemical control along with the catalyst, and then it should be packaged as well. And the packaging can be done using a boxes or bottles or whatever it could be. So let's think if it's a Coca-Cola factory wherein all the Coca-Cola would get filled up in the bottles. So in case if the flow of the bottles is not in line with the Coca-Cola product, what it is getting delivered by these both chemical control and the catalyst control entities, we would waste the Coca-Cola. If we do not have enough Coca-Cola coming as per the flow of the glasses may get broke. So it's extremely important to keep the flow of the packaging material in the product in line. So, considering the similar kind of example, let's go ahead with this diagram. The chemical control entity gets monitored by two sensors, and also there are two actuators which may activate more temperature, or it may activate a furnace to increase the temperature, and the another actuator is the flow actuator probably. So the flow actuator increases the flow according to the command given by the master management control system. And this could be a sensor which senses the flow, and this could be a sensor which senses the temperature. Similarly, even for the catalyst control entity, and similarly it is same for even the packaging control entity. So this is the use case we would be designing using the design patterns. As I said, there are two ways to design this given problem. It could be either using a procedural programming language, or else it could be we can do using a object-oriented programming language. Let's look at the pitfalls of procedural programming language. Procedural programmer, which could be a novice to the complete software industry, would put all the functionalities pertaining to the master management control system into main functions, and subsequent individual entity functions he would definitely put it into the subroutines. The challenge of the procedural programming paradigm revolves around the functionality rather than the data. That's the key problem for the procedural programming language. It would definitely work even if you do, and even if you design the given problem in procedural programming. But there are multiple problems that gets associated with this kind of design, which would unravel only in the future but not at the present. That's the reason procedural programming languages got failed so many times, as they were quite convenient while writing the code. They were not standing up to the mark while modifying or extending the features. But does the object-oriented programming solves all this problem? We will have a look at it. Practicing object-oriented programming merely doesn't solve all the problems. What exactly means by the object-oriented programming? It's nothing but the visualization of a given problem in terms of objects, in terms of real-time objects. Whatever we perceive, see, touch, eat daily in our everyday lives are all in one or other sense, these are all objects. When our daily life is completely revolving around the objects, why not have the software programming in terms of objects? That is the main principle that led to the object-oriented programming development. As an object-oriented programmer, he will consider the given use case, and he will take the master management control unit as one object and subsequent individual entities as different objects, while sensors and actuators are as further different objects. The design for the procedural programming revolves around the functionality but not the data. In the object-oriented programming, the design revolves around the data. And these objects need to be communicated to achieve the desired functionality. We have visualized the given use case in terms of objects. Let's suppose we have completely written the programming in object-oriented paradigm. But does it solve the problem what we have mentioned during the procedural programming. What's the problem we mentioned in the procedural programming is extensibility, scalability, modifiability. But implementing the object-oriented programming doesn't solve the whole problem. It has to be more. Let's look. What exactly are we missing? You have created a perfect object-oriented programming model for a given use case. But what if you need to modify the making process in line with new research results? There is a new research parallelly going on in your factory or the company, and you came up with a new container, implementing a new container with a separate catalyst would give a more taste to a Coca-Cola product. Then how do you implement it in the software design? You need to completely overhaul the existing code to make it work better. Is it feasible? There would be a downtime, and there would be a need for a training. There are a lot more implications for the overhauling of the existing design. Let's look at another problem. What if we would like to increase the factory or application capacity? To increase the application capacity or the factory capacity, you need to put more containers or else the more objects, in case if it is a software application. But does your design supports inclusion of the objects or inclusion of the new containers in the middle without much change and without affecting the existing components? Let's look at another problem wherein, what if you would like to add in new features? If we have done the design in the procedural programming, all these problems will still be there, even in object-oriented programming model. But what is the solution? Let's look at how the design patterns addresses all these problems. Let's build the given use case using the design patterns. The model of this particular manufacturing entity without using design patterns may work at one time, but it would definitely pose scalability issues in the future. As mentioned in the previous slide, there would be a lot of issues which may come up in case if we do not follow the design patterns. Such kind of the designs without using the design patterns will hinder the growth. That's where the design patterns comes into the picture. When building an application, it's important that we keep the future requirements and changes in mind. Otherwise, you will have to change the whole code, whatever you have written. Not only that, implementing a complete new design or overhauling the existing design would pose new issues. It may create new bugs. Building a large application is never easy, so it's very important that you design it correctly and then start coding the application. When there are complicated distributed systems, you need to design perfectly well in advance. That's the reason the design patterns has taken an utmost importance rather than coding. Design patterns provide efficient techniques to create a flexible application design. We will look at how these things can be achieved using the design patterns by going through a small, very few design patterns and implementing and applying those design patterns for a given use case. UML. Why do we need the UML? Till now we have gone through the need for the design patterns and how the design pattern solves the problem. Where does this UML comes into picture? UML is a modeling language widely used to visualize the object-oriented designs. In a complicated distributed system, there would be a myriad of application developers, architects, designers, builders, and all. It would be a very tedious job to get everybody in the same track, because each one of them would have a different design in their mind, and the nomenclatures they might use would be completely different to each other. So how the UML solves this problem? UML makes it easy to visualize the software designs. UML diagrams can be easily decoded and converted into most of the popular object-oriented programming languages. The third point comes later. The primary importance of the UML is to visualize the software design. We know the programming can be visualized using the code, but how the designs can be visualized? And that's where the UML was taking a birth. How the UML visualizes the software design? It does using the diagrams. We will look at the few of the examples of the different diagrams while applying the design patterns for our given use case. But before going through that, let's take a quick glance of what exactly these diagrams are all about. These diagrams have been broadly classified into two: structural diagrams and the behavioral diagrams. The structural diagrams provides the view and the model of a structure of the different objects that are being designed. And the behavior tells about how the functionality happens. It tells about how these objects are getting communicated to achieve the desired functionality. Under the structural diagrams, there are class diagrams, component diagrams, object diagrams, along with composite structure diagrams, deployment diagrams, and the package diagrams. If you closely look at all these names of these diagrams, they have nothing to do with the functionality. They just tell about the objects, what they constitute, and how they are organized. They never tell about how those objects get communicated to achieve the desired functionality. But that whole job will be done by the behavioral diagrams. Behavioral diagrams further classified into multiple diagrams. One is the activity diagram, use case diagram, state machine diagram, and the interaction diagram. The activity diagram tells about the activities that happens across the objects. The use case diagram tells about what is the required functionality need to be achieved using this design in an extremely simple and layman understandable language. The state machine diagram tells about how the whole system state is being transformed from one state to another state throughout the course of the application execution. Let's take an example of a laptop. When you bought a laptop, it would be in a completely dormant state. And if you power it on, it would be in a booting state. And if you completely boot it, it would be in a running state. The whole, these kind of a different state transformations will be depicted using this state machine diagram. The Third one, fourth one is the interaction diagram. The interaction diagram can be broadly classified into sequence diagram, communication diagrams, the timing diagram, as well as interaction overview diagram. In a general, simple applications, you may not see the major importance of these diagrams, but in a complex, multi-threaded, distributed systems, definitely these diagrams takes an utmost important picture. The reason is, when in a complex distributed system, if all these different entities works in isolation, we would not be able to achieve a desired functionality along with the desired performance. The complex distributed systems' main goal is to provide a maximum performance in a short time. And this can be achieved using a multi-threading or multi-process communications and all. When you are having a multi-threaded or multi-process communication or application, all these threads or processes need to be communicated so that they can coordinate the data among them to achieve the desired functionality. So, how these different threads or processes need to be sequenced will be depicted using this sequence diagram. And how these threads or processes communicate will be depicted by the communication diagrams. And when the events need to be sent and received across the multiple threads or process will be depicted using the timing diagrams. The UML takes an utmost important place in the design patterns because unlike the programming languages, we do not have any other means to describe or talk about or communicate the design patterns among our peers. The UML tools. We talked about the diagrams, but how to draw them. There are multiple free open source UML tools available in the market. Some of them are AbstractFactory, Dia, UML, StartUML. They let you create a fast diagrams. And if you are in an enterprise, there is a plugin even for the Eclipse. Most of the major enterprises uses either IBM Rational, Magic Draw, Enterprise Architect, Microsoft Visual Studio.NET. These are the popular UML tools using which you can design a perfect diagrams. This is an example of one of the design pattern which we would be using to solve the given design problem. And this is the AbstractFactory illustration using our UML. What this UML diagram talks about. Let's quickly go to the design problem, what was given to us. We have a master management control system and chemical control entity, catalyst control entity, and a package control entity. Let's set aside this master management control system for a while. Let's design the subparts, the packaging entity, chemical control entity, and the catalyst control entity. Each one has different objects that are interacting with this chemical control entity. These objects are sensors, actuators. Just visually identify the objects. Whatever the perceivable things, what you see in this diagram would end up as an object in your design. Visualizing a problem using object-oriented design is a skill that should be developed by an experienced if you are a strong procedural programmer, it would take a while to visualize any software problem in terms of objects. So visualizing a given problem in terms of objects is must for the design patterns to better perform. If you do not identify the proper objects, the design patterns will not solve the whole problem, whatever we have talked about in the previous slides. So, as I said, here there are 4 objects. Then among them 2 are sensors and the 2 are actuators. So let's design these actuators and the sensors. In a procedural programming languages, normally people tend to create functions for them. But here we need to create objects for the objects whatever we have perceived. There are 2 entities, actuators and the sensors. And each one of the entity has different types. The flow actuator or furnace actuator. And the other one is flow sensor and the temperature sensor. So let's suppose if the client of the software application would like to design this application, and then he need to create these temperatures or flow sensors or the actuators for a given entity before let them communicate to each other or with the control entity. The first and foremost important point is we need to create those objects. There is a classification among the design patterns also. One is creation of design patterns, one of the most important one, and then the structural, and then behavioral design patterns. For any software design problem, the first thing which would come up is how to create those objects. And the creational patterns addresses quite a few problems that our software architects have encountered in their experiences in the past. One of the popular creational pattern is the AbstractFactory Pattern. It is a one level complicated than the factory pattern. In the factory pattern, when you ask the factory to give you an object, depending upon the type what you are asking, the factory would generate a particular object. But the AbstractFactory generates a factory itself. Let's look at the AbstractFactory over here. This is an actuator factory and this is a sensor factory. The client has asked this AbstractFactory to give you either a sensor factory or actuator factory. Once you have a particular factory, you can further ask for either flow actuator object or the furnace actuator object. Similarly, even for the sensor, you could ask for a flow sensor or the temperature sensor. I have a code ready for this given AbstractFactory design. Let's take a quick look at this code. Before going to the details of each and every file, let's look at how we are using the whole of this software design. So here, let's think this is the client who is trying to create a objects for the actuators and sensors. Here the factory producer is one of the static methods. You are asking to get a particular factory. If you pass on the string as an actuator, you would get an actuator factory. If you pass on the string as a flow, you would get a flow actuator. Because as you already got the actuator factory, We are further asking the actuator factory to create a flow object. Similarly, once you get this flow object, you can call the respective methods on top of the delivered object. Similarly, you have got this actuator factory, and further you are asking the actuator factory to provide the furnace object. You are passing the furnace, and then you are getting the particular furnace object. On top of the furnace object, you are asking them to initialize the element. These particular methods you could add depending upon the type of and the number of the different behaviors for a given object. Similar to above, we have a sensor factory as well, and also the flow sensor and the temperature sensors. So this is the way how the client uses our design. Now let's start going through the basic design. You have an actuator with a particular object, a particular method called initialize element, and the flow is a subclass of the actuator with the overriding of this method initialize element. Similarly, you have a furnace subclass with the overriding of the initialize element. You need to understand that initially the furnace and flow are the type of actuators, and you should be able to visualize that both of these actuators share a common behavior. If they share a common behavior, you create an abstract class called actuator, and then you are deriving and overriding those methods. It is extremely important to identify generalization, also called the subclass superclasses for a given design problem. It's extremely important for this AbstractFactory pattern. You may ask, can't I implement the AbstractFactory pattern without these subclasses and superclasses? No. The reason is, the whole idea of the design patterns is to simplify and provide an extensibility for a given design. Let's suppose tomorrow, in case if you bring a new actuator called a flow or temperature or a pressure actuator. If you create a completely new class, you may have to, then you would have to change the whole design of the main method, how the client uses the software application. If we know the pressure actuator is also a type of an actuator, we could easily derive the pressure class, a pressure actuator class, from an actuator interface. Then you may have to create a new file called pressure.java, and you just need to add another line over here to get a pressure object from the actuator factory. It's quite simple to introduce a new feature for an AbstractFactory design pattern if you would implement using that. If you used procedural programming, it would be extremely tough to do such a kind of change. Similar to the actuator, you have a sensor factory as well. Temperature and the flow sensors. We would be sharing this code So this is how we can illustrate the AbstractFactory design pattern, which is one of the most important design pattern among the whole design patterns. During my experience, 60% of the times I used this design patterns. I mean AbstractFactory design patterns, because if you create the objects correctly and properly, it would be easy to continue the design of the remaining software. The reason, if you mess up with the initial creation itself, it would pose quite a few problems going forward in your software development. So the creation is the first and foremost step, and these creational design patterns solves most of the design problems you encounter while creating the objects. Next, the observer pattern. So one of the most popular behavioral pattern is this observer pattern. Let's take a small example. Like, you have a subject and one observer is observing it, and let's suppose you need to monitor a temperature or the flow or something. You need to keep polling that subject. That is a performance bottleneck. What if subject itself notifies the observer that I have changed? It would be a very simple design, and along with that it would add a much more performance, because you need not to keep polling the subject, which would take up the instruction cycles of your CPU. This is an illustration of the observer design pattern using UML. Let's create a subject initially itself with a methods that would enable the observer to get updated. If we have already created a subject and observer without considering their future requirements, we would not be able to solve this problem. We should understand that there would be an entities who would be interacting each other, and there would be an entity called subject, and there would be an entity called observer. Let's take the same example what we discussed. As I told you, the packaging entity should monitor the delivery of the product so that it can adjust the packaging material as per the product output. So, whose job is that? Who has to monitor the other entity? Let's take this. If you consider packaging is the subject, if you closely look at it, and the another one is the chemical control, it would be an observer. Packaging not only gets observed by chemical control, it can be observed even by the catalyst control. So you have added few of the methods that would enable to attach an observer or detach an observer. So let's suppose if the subject gets changed, subject knows it that it got changed. So what it obviously would do is it would notify all the observers that has been attached to the subject. Subject maintains all the observers list who has been attached to it. And once it notifies the observer updates its state. Let's suppose there is a problem in the supply chain of the packaging material. What it would do? It would let all the observers know there is a problem in my packaging flow. So control your chemical composition and flow so that it would not spoil or waste ore. Similarly, not only the packaging can be a subject or chemical control would be an observer, it can be vice versa as well. Without the observer pattern, it would be a completely performance bottleneck if you design using the procedural programming or any other object-oriented programming as well without using this observer pattern. Final one we would like to give a quick glance is the mediator pattern. We have quite a few entities in our given example: chemical control, catalyst control, and all, packaging control and all. And each one has to communicate with each other, and each one of them again has to communicate with the master control entity. If we open multiple communication channels, it would be very hard to debug a problem in case if some problem arises in the factory, because there are thousands and thousands of communication channels between each and every actuator and all. Isn't it a big problem? It's neither for debugging nor maintaining as well. Very good. But how to solve this problem? It's a mediator pattern. This kind of mediator pattern we normally see in our day-to-day lives at many instances. Let's suppose you have a on-site counterpart, and then there is one more team in the on-site, and we have an offshore team over here of 10 people. We let each of these 10 people in the offshore to communicate with the 10 people in the US on-site or whatever. It would create multiple communication channels, and at the end of the day we would not be able to know what has happened. And in case if some communication gap arises, we would not be able to identify which one and what has gone wrong. And there would be a time waste even for finding out what has gone wrong as well. So it's not good for either debugging or maintaining. So what we would do normally in our in this simple example, what you would normally do, we will be having an on-site coordinator whom you would be talking every day. The on-site coordinator would pass on the requests to the on-site team. The on-site coordinator is actually playing a mediator. And this mediator pattern is nothing but the similar kind of principle following. So let's quickly go through this UML. The mediator, and you are materializing using this concrete mediator. And we have a colleague, and materializing using this concrete controller or colleague, whatever. This concrete controller is our controller units for our given factory. So you can create any number of colleagues over here. But to talk to the other side, the communication passes through the mediator. Even if it is in between these two concrete controllers, the communication happens through the mediator. With this kind of approach, in case if something goes bad among the communications between different controllers, we would be able to identify easily using the mediator logs. Mediator normally possesses the logs of all the communications. So it would be very easy to debug and easy to maintain. In case if you bring a new controller, you need not to create the communication channels with all the remaining controllers. The new controller should just communicate to the mediator and everything else falls in place. Look at how simple the design is if you use the design patterns. So the design patterns not only solves the regular design problems what software architects and designers encounter, it also solves all the future problems that it anticipates way ahead. That's the beauty of the design patterns. Let's conclude our design pattern session. Similarly, there are other design patterns to solve majority of the problems that software designers encounter during their daily activities. Not only these three, there are a myriad of design patterns that solves each and every minute problem you would have definitely encountered during your experience. You need not to reinvent the whole wheel. You just need to follow the design patterns, which are all well proven in multiple contexts. It could be either application domain or service domain or a product domain. The design patterns serves as a common web. Design patterns complements one's experience and helps them deliver a wonderful and successful software designs. That's the reason big Tier 1 companies like Google, Amazon, or Microsoft, or whoever it could be, looks for the people who has an experience in the design patterns, because they deliver wonderful designs. And they serve as a common nomenclature or jargon that architects can easily communicate with each other in the software design. In our day-to-day lives, we talk to the different software people or your colleagues or peers regarding your code and design. You need not to give all the nitty-gritty things. You can just tell them, I have followed AbstractFactory Pattern. That would make the other guy easily understand how the design you have done. It's the beauty of design patterns. It makes the common nomenclature. Software design is no more an art. It's a skill one can learn. Prior to the design patterns, people encounter multiple design problems, and everybody does their own design that is completely different than others. And you need to struggle a lot for that. It's a no more an art now using these design patterns. It's a skill. You just need to follow the particular design pattern and code it. In our Edureka course, we would be covering the design patterns in 8 modules. The module 1 would cover introduction to design patterns. Module 2 would cover different creational design patterns. And module 3 would cover the different structural design patterns. 4 would be behavioral. And the 5 would be concurrency design patterns. The 6 is the anti-patterns. 7 is the refactoring. The refactoring is one of the key parts which you would be learning how to modify your existing designs using the design patterns. And the final module would be a project. So I have seen one hand raised. May I know the question, please? We can put it in the chat. So Vignesh Dhananjay, may I know your question, please? Hi Vignesh, I have enabled your mic. Please go ahead.
Hi, I want to basically know the difference between framework and design pattern. I mean, does it go hand in hand, or it's completely different from what framework is, and I just want to know.
Okay, I'll give one popular example. This is object broker. You might have seen object broker, wherein let's suppose an entity which would be on one system and an entity which would be on another system, both would like to communicate each other, but there would be a lot of marshalling and unmarshalling of the parameters, and the data need to be done while passing and receiving the requests. So what this object broker does is it will mimic you, it will provide a false or a mock entity in the first system itself. What the request does is it would communicate to the other entity as if it is talking to the entity which is present on the same system. In fact, all the underlying overhead of marshalling and unmarshalling of the data will be done by the object broker. So this is one of the popular design patterns. Okay, there is a lot of research value, and there are a few frameworks designed around this object broker as well. So if the application, or if you are in a company wherein most of the applications are distributed applications, what they would suggest you to use is this object broker framework. It is backed by one proven design pattern. Still have a question? Hello, Vignesh?
Yeah.
I have given an example like So need not to be all the frameworks need to be backed by the design patterns, but this is one of the popular example I have come across in my experience, wherein this framework was backed by a design pattern, because all these application developers need not to bother about the designing using their code. They can just use this framework. It's actually like, the design pattern simplified the object-oriented programming, and the framework simplified the design pattern.
Okay, I got you. Yeah. Thank you.
Thank you. Any other questions anybody has? So with this, I'm concluding the session. If anybody has any questions on the course content, what we would be covering in the whole Edureka session, I'm glad to help you guys. Our Edureka course on design patterns would be completely comprehensive. By the end of the whole course, you would be able to easily design any sort of design problems you may encounter in your regular day-to-day activities. It would simplify the whole of your software jobs a lot. Not only that, these design patterns are becoming a bread and butter of all the Tier 1 companies these days. If you could go through the job portals, one of the main skills that Tier 1 companies are looking at these days is the design patterns. It's not the data, like, if you understand there are 6 creational design patterns, 7 structural design patterns, even if you understand the definitions, that doesn't land us the job in these Tier 1 companies. It is the skill how you apply them to solve for a given problem. There are multiple instances where you apply wrong design patterns for problems that would land into issues that you would never imagine. This one of the module covers all this kind of applying the wrong patterns to the designs. That module 6 is anti-patterns. There are sub-classifications in the anti-patterns as well. We would be covering deeply about these anti-patterns. Excuse me. Excuse me. And the project and retrospection of our module 8 is we would be covering a project which would cover a major design patterns what we would be learning in these previous modules. Definitely it would be an added advantage for the people going through the course. There will be a feedback form coming to you guys. Organizers will be sharing the feedback form. Please share your feedback regarding the webinar. And if you have any kind of questions related to the course content we would be covering, I'm happy to help you. And the requisite contact details will also be shared. Happy learning. Thank you.